Alright, so I know it's been quite a while. I started tearing my workshop apart, trying to clean it up, and I should have just left it alone for the time being because it's even worse than before. Seems the more I clean, the dirtier it gets. Anybody that's kind of in a cramped area knows what I'm talking. Well, I should say a cramped area with a lot of stuff knows what I'm talking about. You just keep moving stuff around, and nothing ever gets cleaned. So right now, I'm actually working in my bedroom on just a table, and it's not the best setup. I'll tell you that right now. It's just my camera, my phone, and we'll see if we can get this battery at least done so I can get it back to the owner. It's been quite a while. He's got a ton of them, so he's not really worried about it. And he's my brother, so it's not that big of a deal. But I do want to get it back to him, and I want to finish this video. So let's take a look. Where we left off last time, and again, excuse the quality. I don't even know how this is going to turn out, but yeah, we'll find out. So if you remember last time, and I'm sorry about the lighting, yeah, it's going to do that. Try to just block it out. If you remember last time, two of these cells, if you're, they're in parallel, so you got these two, these two, these two, these two, and these two. So if you remember, this bank right here was not holding a charge. Now, most likely it's just one of these batteries that's bringing the other one down. But the other ones hold just fine. Now, this has been sitting ever since I did the last video, so that's quite, a good amount of time, and they're still holding about 3 volts. Now, it's still under the minimum for this board to operate. And as you see, when I push the button, nothing happens. So what I want to do today is pull this board off and clean it. Now, there's a lot of conformal coating, and I don't have it in front of me. And I forgot to look at the name, but somebody commented about, I think it was this. And you're absolutely right. There is a lot of corrosion and buildup, so I do want to get that off. Now, like I said, there is conformal coating all over it, so we'll do the best we can. I don't know. I'll see if I can fix it. I'm not really sure, but we'll find out. So first thing I want to do is try and get this board off, and I have to desolder all these terminals going to the board, because I don't want to just start scraping and shorting something out and make it worse than it was. And then we'll pull the batteries out and see about replacing one of the batteries.
So this is about the time the audio went completely out, so I'll just summarize the rest of it. As with any desoldering job, it always helps to add some new solder to the joints. I then used a desoldering iron to remove as much solder from each of the joints as I could. Unfortunately, the desoldering iron that I have isn't that great, so it didn't get all the solder off. And this happens sometimes. When it does, I just heat the joints up and pry the board off. It's probably not the best practice, but it works. I got a bit overzealous though, and when I was prying the board off, I forgot to unsolder the thermistor. So I'll have to fix that later. You can see here, this is where the thermistor is. It's kind of epoxied in place, and the wires got ripped out of the board here. After double checking which pair of cells were bad, I went ahead and removed the nickel strips. This side I'll simply remove from the cells since they're only connected to cells and the board. However, I'd like to reuse the tabs on this side, since this strip is also connected to not only the board but other cells. So I'll have to be careful about how I remove them. The best way I found to remove these tabs, or strips, which are spot welded on, is to just use a pair of needle nose pliers to gently pry and roll the tab off. Once I got everything disconnected from the batteries, I was able to push them through and get them out of this case. That was easier said than done. If you can imagine these batteries being in the pack, I used this failed print and just kind of put it on the top there by that rubber piece and just kind of hammered it out. I would not recommend anybody do that, but that's how I had to get these get them out of there. Yeah, I would not recommend anybody use hammer on a lithium cell. It's not a good idea at all. That's pretty much what I did here. And like I said, I used the rubber piece in the middle. I put most of the force on the rubber piece in the middle to get it to slide out of the enclosure. So now I just have to find a couple cells that have the same milliamp hour rating as the ones that are in here and are somewhat balanced, or they're somewhat similar as far as their internal resistance. I'll do a video on that at some point, how to measure the internal resistance, but basically it just means the health of the battery. So I have two here that I already picked out. I'm actually going to ditch both cells that were already in this pack, simply because if one was bad, it was bringing the other one down with it. Both were discharged for long periods of time, which were not good. So I'm just going to replace them both with two known good cells. Once I get the cells back in, all that's left to do now is straighten out these tabs on these nickel strips and spot weld them down to the battery, or to the cell. So as far as the board itself is concerned, everything on it is a surface mount device, and it's got some conformal coating on it. And without a microscope, it's in a hot air station, it's extremely difficult, if not impossible. Well, it's not impossible, but extremely difficult to work on these types of things. So my plan here is just to clean the board, get any corrosion off of it, and see how things go from there. I'm going to be using one of these contact cleaner pens. These have a fiberglass tip with isopropyl rubbing alcohol inside of them. These work really well and are fairly abrasive, and I've had good luck in the past cutting through conformal coating with them. The other option would be to use a toothbrush. If you want to be a little bit more delicate, you can use a paintbrush, but because of the conformal coating, I'm going to go with this. I saw what I thought was a crack in the solder at the base of one of these capacitors, so I figured I'd just refresh, the solder on all of them. Really did the best I could with what I had, no microscope, just a wedge tip iron, and it worked, but I'm sure I could have done better with some flux and hot air. So this is the spot welder that I built just for this purpose, and you can hear the batteries actually. Yeah, you can hear the batteries kind of low. I have the power supply hooked up to it, but it needs a full charge. It did do the job, but I'm going to be building a new one soon, using an Arduino, and I'll make a video on that. Now what I'm doing here is just adding the ground lead. When I took the board apart, this piece was so convoluted and bent that I decided just to get rid of it and use a piece of wire instead. It should work just fine. I scuffed up the metal first, and the solder seems to be adhering to it, and it's pretty sturdy. So here I'm just using a power supply to charge the pack up beyond its low voltage cutoff. The idea here is just to get it ready to slap back on its own charger and let that do the rest. And there we go. It's actually shown a charge now on the meter. Before, it was just flashing the first light and would not go past it. It still worked on the drill, but it would, you know, that first light would always blink. It wouldn't actually charge the pack. So, looks like we're good to go, and I can give it back to its owner. Sorry for the low quality of this video, but I'll see you next time. Bye-bye.